And welcome back. So in the last tutorial we added these waypoints. I just realized that I might not have covered what happens when you use the waypoints. So let's cover that just quickly right now. So remember, there's that interface that we implemented on the guard character, and so what you'll get is that you can place this interface node, which is the interface for the setNext waypoint function. So essentially that interface allows us to create this node, and remember, it passes in the new waypoint and the current waypoint. We maybe want to check the current waypoint to see if it's the one we're already going to before setting the next one inside this guard target, but for now we'll leave that out. So all we need to do is we set the guard target on this class. Remember, this isn't necessarily the behavior tree stuff, this is just so we can actually see where we're heading inside the details panel of the character. So if we select the character, it's just so that this value gets set, and then we get the blackboard from the object, set its guard target to our guard target value, and we also set a boolean to say that we actually used the current guard target as a waypoint, and I'll cover that in a later video. So I want to talk in this video about these waypoints, because right now they're kind of simple waypoints in that all they do is they point to one other waypoint, right? And that's kind of all right, but we probably could make those a little bit more interesting. In that, what we could do is we could add some logic into them to do a little bit more, to give them some more behavior as designers that we might want to play around with. So we need to extend this waypoint. So let's make a duplicate of it. Duplicate, where's duplicate? Great copy. Why don't I just call it duplicate like everywhere else? So let's call this random waypoint. It's essentially the same thing. Okay, so let's drag that into here. What we want to do is we want to, in somewhere in this graph, we want to do something a little bit more interesting. So what we're going to do is we're going to let's just break this node, and we're going to do some more logic in here. Now I'm going to show you a set of logic that does a thing called weighted random selection, but we need a few variables to start off with. So let's start off with the first one we need is that we need an accumulated weights value. So we need a value that is an accumulated weights, and I'll explain why that is in a minute. Let's create another variable, which is the weight count. We need a random float, so let's call it random float. Oh, let's call it random value. You can see it's a float from the greenness. So what else do we need? Well, we need a set of waypoints. So let's just save and compile that. Now in order to use these values, what we need is a structure to hold some data, and it just so happens that I've already created that structure. Where are we? What's it called? So if you right click in a folder and you go, hold on, let's just find. If you right click in a folder and go blueprint structure, you can create a data structure for your blueprints. And in this case, I've already created one earlier when I was testing out some of this code. So let's have a quick look at it. So what it means is that in the structure you can essentially just add new variables to it. It means that you can package variables into a structure and use those structures in things like arrays. And so what I've got is I've got a structure with an actor value, it's got a floating point weight value, and it's got a normalized weight value, and that's the important bit, the normalized weight. So this structure I've called weighted actor. And so what we're going to do in our random waypoint is we're going to create and it's going to be a weighted, it's help with the spell, wouldn't it? Weighted actor. So it's going to be let's call it waypoints. It's going to be public. Okay, so the waypoints is going to be an array. So we click this little thing that makes it an array. So what else do we need? Okay, so from here, let's start adding some code. First thing we want to do is initialize our variables, but I think we'll do this as a sequence first. I like to do sequences if we're going to do complex code because it keeps the thing from getting a bit messy. And we're going to need, I think it's four pins for our sequence. So okay, the first part we're going to need to do is we're going to need to initialize our variables. So let's we just drag on accumulated weight, weight count, random value, yep, random value, and our next waypoint, we need to clear that. So what we can do is we can drag off from our first, let's just make a little bit more space. Yeah, okay, that's as good as we're going to get. So we want our accumulated weights set to 0. We want our, let's just line these up. Call me picky. Weight count set to 0. We want our random value to have a random float. So we need a random float. And it needs to be a value between 0 and 1, so the random float should give us that. So let's give that a box. Initialize variables. Okay, so that's good to go. So what we need to do then is we need to accumulate weights, and what we're essentially saying is that this waypoints array has a number of weighted choices. So for any number of elements in there, what we need to do is we need to sum up all of the weights for each choice. I'll show you what that means when we actually sort of add it to the world. Which means that we need a for loop. So let's for specifying the for loop. So we just need a for each loop. And the array is the waypoints array. Let's drag the exec pin into there. So for the loop body, all we're going to do is set the accumulated weights. Because what we're trying to do here is calculate the sum of all of them. So we take the array element, we need to break that. You'll see that it's got a break. So for each element in the array, it runs a loop body. We take the weight and we add it to what's already in the accumulated weight. So drag the accumulated weight into there. So what we're doing is with these nodes, we're summing up. Oh, no, didn't want that. Come on. We're essentially creating the sum of all of these weight values in this array. So let's add a comment there. Calculate accumulated weights. Okay, that's part's done. So the next bit is that we need to then divide all of the weight values by the accumulated weight and store that in the normalized weight. So again, we need to do a for loop. Let's for loop. No, don't want that version of it. I want a for loop, a for each loop. And again, waypoints is the array. Oop. Can you just drag it onto the array? There you go. A sign. And a crash. Okay, we're back. Yes, just had a little bit of a crash. Nothing to worry about. Nothing to see here. Okay, so we've done our accumulated weights. So we're looping through each weight. We're breaking the weight actor struct down. We're adding the weight value from that struct to our accumulated weights and setting it back in accumulated weights. So basically, we're summing in this part. We're summing all of the weights for any weights that we've set in the waypoints list. So in this part, we're going to take all of our waypoints and we're going to normalize their values. So what we need to do is we need to break this. By the way, you won't see this break weighted actor until you've fed the waypoints in, because it doesn't know what the element is supposed to be. So what we need to do is we need to set the value of our normalized weight to be the weight divided by the value that we calculated for the accumulated weight. So essentially what's happening is that we're taking all of those values in the arrays, summing them up and then dividing them all by the sum, so that all of those values shift into the space between 0 and 1. And that's called normalization. So let's just move those things up a little bit. So we need to take the weight, we need to divide yep, we need to divide by the accumulated weight. We then need to do a make normal make weighted. So we're going to put our normalized weight in there. We're going to put our weight back in. We're going to put our actor back in. And then we need to set array element, and in a waypoints array, and the target index is this index, and the item is this item. So let's just connect that up. So what essentially this block is doing is, let's just add a comment block around it. Calculate normalized weight for each element in the array. So I'll show you an example when we actually get to using this. Oops. Let's just move those up. I think it's useful to sort of comment your code a bit like this. Oops, we haven't connected that one. So we've gone through, we've initialized some variables, we've calculated the sum of all weights, we've divided each individual weight by the sum to get a sort of a normalized weight for each version, and here's where the complex bit comes in. So what we're going to do is, this time we're going to do a for each. We're going to do a for each loop with break, because what we want to do is we want to step through our array. So let's just drag the exec onto there. We want to step through our array, and we want to first off, we want to, let's just break our value. We want to add the weight of this guy onto an accumulated value, right? So we're using weight count here. So let's just get that. So we need to add the current value of weight count and the new weight. Let's just drag those onto the right pins because that annoys me if I don't. We need to then check to see if these are greater than our random value. So here we do greater than or equals random value. Might just move that a little bit. You can get really picky about these things, can't you? So we're saying for each weight in the array, we're going to add it to an accumulated weight value. So basically we're adding until we're either greater than or equal to our random value. So what we're actually saying here is that if the weight value for this current element takes us over the value of our random value, then we know that the random value is the current weight. So the random value lies within this current element's weight interval, so to speak. So we're going to do an if branch there and say, okay, so that's true. Well, so we're saying if we've currently hit the accumulated weight that would take us past our random value, then it must be inside this element where we're doing that, so we can actually set our breakpoint. So we can set this, let's just do it over here, set our actor into a breakpoint. This is going to be horrible, isn't it? And then we can break. So essentially, yeah, that's just awful. So essentially we're going to loop through all of our structures. We're going to add the weight value onto this weight count variable, and if the weight count variable added to the weight is greater than our random value, then we know that our random value is the one that the random value sits within, and we're going to set the waypoint for that index. Otherwise, what we're going to do is we're just going to add our weight value. Let's just say plus. We're just going to add our weight value onto weight count and store that into not that way, that. So what we're saying is, if this value lies in the interval where random value is inside it, then we're going to set the waypoint. Otherwise, we're going to add the value that we got into our accumulated weight and then continue looping. So when we've completed that for loop, we can then exit back again. So let's just make sure I've saved that so we don't get another crash. And so let's just add a comment block there. Set which waypoint lies within the current random value range. It really gets those errors when I move things, but whatever. So what we can do now is that we can use one of these random waypoints. So if we place one in the world, they look just like normal waypoints. Let's place one over here. Oops, that is not what I wanted. Let's move him over here and drop him to the floor. So with this guy, I'm going to move him over here, create a copy of him and move him over there. So if you look at this one, now we've got a waypoints array, and we can add two values into that array. So the one we're going to do is we're going to point to waypoint 3 and waypoint 4. So random waypoint is going to point to waypoint 3, and waypoint 4. And now here's the thing, right? So this is basically our array, and we can give it any number we want for our weight. So if we give it an even weight, what's going to happen is that when it steps through that array, it's going to sum these two values together. So it's going to say, okay, this is a value 100, we're going to add the next value onto that, so that's 200. Then it's going to take each of these values and divide by the accumulated value and store that in normalized weight. So what will happen is that 100 divided by 200 becomes 0.5, 100 divided by 200 becomes 0.5. So each one of these will get an equal weight. Yeah, so the value in here is a relative value relative to the other weight values. It's not an absolute thing, it's not a percentage or anything, it's just it's how much of that 0 to 1 space the value is going to take up. So if we did 200 here, we would get this value plus this value would be 300, so we get 200 divided by 300 in here and 100 divided by 300 in here. So you'll see that the value would be bigger in this member than it would in this. And that's what weighted random selection basically does. It uses it sums up all of the possible values, divides by the sum, and for each one of those values it essentially shifts the space down into the 0 to 1 space, so they all become less than 1, but the amount of that 0 to 1 space they take up is proportional to how their relative values are. Which is kind of useful, right, because we can then tweak these weights to give us the effect we want, right? So if we want a 50-50 choice, we just put two equal values in there. If we want a higher choice in this one, we just increase this value. It's just a relative value, it's not, and there's no absolutes in there. So in this case, what we want is I think we should be alright actually. That should point to waypoint, yep, and that one should point to waypoint. So all we need to do is then point this one to a random waypoint. Yeah, so essentially we can use either simple waypoints that'll do this to that, or we can do a random waypoint where it's doing a weighted random, which will choose either of those two. And we could, interestingly enough, right, so if we did this as a weighted random, we could actually have it connected back to here, right? So this is all about sort of one-way graph kind of things, but we could actually go backwards and just have a very small chance of that backward link being taken. So essentially you can have a two-way kind of thing. So maybe there's another network of waypoints around here and they're connected by these kind of very occasional weights. So we can say, right, we only ever choose this path maybe 1 in 10 times kind of thing. So we just give it a tenth of the weight of the other choice. And that means that we might be sort of patrolling this path, and then every now and then we'd go to this one and we'd patrol another path, and then every now and then we'd go back to this one and we'd patrol that path. It's surprising how much a simple bit of mathematics can give you a much more interesting kind of setup, right? And it just means that there's a little bit more logic, and we could put some more logic in here again. So let's just see how that works out. So what we should see is that this guy comes to this and decides which one of these to go to, and he's going to that one to start off with. And he's choosing that one again. And choosing that one again. Of course, this is random, so you know you can't exactly tell what you're going to get. So before we demo what's going on, just a quick update on as we were editing. I was using the weight value, but of course we should be using normalized weight. So what we're doing is we're accumulating normalized weight into the weight count and checking to see if the current normalized weight is over our randomized value, and if it is, we set the waypoint. If it's not, then we just store the current count of the weight and keep going through the loop. So essentially we're just summing up until we reach something that will either go over or is equal to the random value, which means that the random value lies within the previous weight and this weight's normalized weight's value. So what we get if we simulate that is that we get the random choice from this node to go to either of these two. Yeah, so 50% of the time it should go to this one, 50% of the time to go to that one. So there you go, weighted random selection, and you can use that weighted random selection algorithm in all sorts of places. You know, things like weapon choices. You might want to give like weapon choices some kind of weighted random to choose which weapon to go for. You can use it for all sorts of selections. Maybe we should sort of add a node in a behavior tree that does weighted random as a choice. That's not a bad idea. But anyway, there you go for this video. Sorry about we had to edit it a little bit, but obviously some of the things went a little bit wrong as I was doing them. You know, usual stuff. So I hope that gets you some guys moving around. Obviously there are kind of things to fix up, like the guys stopping at each waypoint. He's stopping because there is actually an idle kind of state that kicks in after he's reached each waypoint. We can always tweak that a little bit, but for now that's kind of got him moving around at least. So give that a try, and I'll show you some more interesting stuff in the next mob video. Thanks for watching.